Hello everyone. Today I will discuss the work, power and energy. Previous class I will discuss work, definition of work and detailed description of the work and a detailed description of the power. And today I will discuss the energy, definition of energy and application and its scientific uh, terminology of energy. Energy is generally defined the capacity, either ability of doing work of a substance, either quantity, either amount of work performed by a body define the energy. Okay, energy is a scalar quantity. Energy generally measure the amount of work done uh, in a, by a body that the body will perform. Measure the amount of work done that the body will be performed. Okay, so ability of work done generally define the energy. So energy is a scalar quantity and unit similar as work, joule and arc. Other unit also we energy as other units as like kilowatt hour. Okay, and also electron volt. It is very important. Electron volt you will be discuss in modern physics. Electron volt generally the when electron passes through 1 volt potential, the acceleration gained by the electron is generally defined is electron volt. Okay, and also another unit is calorie. Calorie generally you will be studied in heat chapter. The calories define the amount of heat required to rise the temperature of 1 gram of liquid to 1 degree centigrade. Rise the temperature 1 degree centigrade is defined calorie. Okay, this is the unit of the energy, and now we will discuss the different form of energy. Different form of in our total energy in our universe is manifested in different form of energy, as like mechanical energy, heat energy, light energy, sound energy, nuclear power energy. Okay, so different type of energy is manifested surroundings in our universe, but in this chapter we will discuss only mechanical energy. Mechanical energy define the amount of work done when the body will be transverse from one point to either moving from one point to another point, either the position, either the change of configuration of the body is generally change of configuration by the body is generally defined the mechanical energy. That means the work done by the body due to the change of the position, either configuration of the body is generally defined mechanical energy. Mechanical energy two type. Mechanical energy generally we define here. Mechanical energy two type. One is kinetic energy and another is potential energy, but here we discuss only kinetic energy. Kinetic energy is the the amount of work done by virtue of its motion of a body is generally defined the kinetic energy. That means when a body is moving, the body must do some work to perform his motion. Then the energy consume, either expanding for moving the body from one point to another point, generally defined kinetic energy. Okay, so due to the kinetic energy arise when the body will be in motion. Okay, and now derivation of the kinetic energy. Now we think a body of mass m moving with a velocity, initial velocity u. Okay, So now this body is moving with the initial velocity u. Now suddenly the body, you think the car moving with the velocity u, and suddenly the car apply a brake, and after displacing after a distances, the body will stop. Okay, we think due to the retardation the body will be by applying the brake. Okay, the uniform retardation from retardation A. So by applying by the when the car will apply the brake, the force applied by the car F. Okay, the force F, when the force F applied by the brake, then the car will be stopped at a distance S from its initial position to its cover S distance and stop due to the uniform retardation. Okay, so the body will be moving, you think the car will be moving in that particular direction. Now car will apply a brake, that means car will be opposing the motion, against the motion. That means the body will be moving that direction, but force is applying in opposite direction. Okay, so that's why they can anti-parallel, and angle between them is 180 degree. Okay, angle between the force, application of force and displacement is 180 degree. So work equal to F S cos 180 degree. We discussed previously work done equal to F S cos theta, so now equal to F into S. Okay. Okay, now we will discuss here. Here also be one thing will be noted out, that F is equal to work done equal to minus of Fs, but this work done against the retarding force, against the motion of the body by the retarding force. Okay, due to the motion is positive direction, you think, and the retarding force is negative direction against the motion, that means work is negative. Okay, so minus of Fs, that means work equal to Fx. Now the body move F equal to, so now F equal to m into retardation into S. Okay, this, and now we know that v square, the body, the final velocity is v square equal to u square minus 2ic. We can calculate the A into S to point out the form of kinetic energy. As we computed as like, we know that v square equal to u square minus 2ic As for retardation. So 2as equal to u square and as equal to u square by 2. So work equal to m u square by 2. So that means this is the kinetic energy. The when a body moving with a velocity u, then the kinetic energy m u square 2. That means work done by the body to stop the motion is known as the kinetic energy of the body. Okay, equal to half into mass into velocity square. Okay, velocity square. So this is the mechanical energy, mechanical kinetic energy of the body. Okay, now we will be discuss the potential energy. Now will be another thing for variable force, for you think variable force. Okay, so if we consider a body moving with a velocity u1, and after certain time its velocity is v1, but the force applied on the body is changed in a time interval delta t. The F apply on delta t second, and the displacement of the body is delta s. Okay, similarly F1 force is applied for that interval of time, and now F2 is force is applied on delta t2, and displacement is s2. So total work done equal to F into delta s1, F into delta s2. Similarly we can find out the work done by the body by a variable force equal to summation of summation fi delta si. Work equal to summation of I fi dot of si. We can find out previous class. So now this can be write as F into ds, and we consider F and S angle between them is angle 0 degree. So F equal to m into a ds. So a equal to, we write m a equal to dv dt into ds m, and dv ds by dt equal to, we write equal to v into dv. And now initial velocity of the body is u1. After certain time the velocity is u1 to u2 v. So then we can write m v square by 2 equal to u2 v equal to half v square m into v square minus u square. So that means the work done by the body when it is moving with a variable velocity with application of variable force, the work done by the body equal to change of kinetic energy, define the total work done by the body. Now we will be discuss the potential energy of the body. Potential energy generally define the energy possessed by body due to its shape, either configuration of the body, either change of the position and configuration, both is defined as the potential energy. Okay, so here we'll be find out the potential energy of a body. Generally here two type of potential energy we can discuss. One is due to the gravitational potential energy, another is elastic due to the elastic motion, either elastic vibration, either elastic potential energy, body due to the elastic potential energy. So gravitational potential energy generally define a body will move from its initial position. You think a body will be raised in surface of the earth surface, and now we will be shifted, either lifted h height from his original position. H height you can shift it, and a to b position you shifted, then total work done equal to force into displacement, and displacement here equal to h into f. F equal to, you know that if m mass is lifted from a to b, then weight of the body equal to m into g. Weight is equal to the force due to the gravitational force. Mg is the gravitational force attracted toward the earth surface. Okay, so this is equal to F equal to mg into h. Okay, this is the potential energy due to the gravitation when we lifted a body from one point to another point. Okay, now similarly elastic potential energy generally defined the when we elongate, either compress a spring, then the work done by the body due to the change of the shape of the body is defined, and the amount of energy stored inside the body is defined as the potential energy. So we can deform the body, and then against the its internal force we can work done, because a body is its natural shape, but we can apply some external force and deform the body. That means we again apply force against the body natural force. That's why the work done by the body to change the body shape, either configuration, it is the energy stored in the body as in the form of potential energy. This is called elastic potential energy, and elastic potential energy form is k equal to half delta x square if k is string constant and delta is the length elongation by application of force, the elongation either compression by the application of force. Okay. Okay, now we will be discuss the conservation of mechanical energy. Before we discuss the conservation of mechanical energy, we will be discuss the conservative force and non-conservative force. Conservative force is defined when we lifted, either shifted the position, either when we took the body from one point to another point, the body must be do some work due to the change of position of the body. So due to the position of the due to the change of position, the body must be do some work. If the work done by the body is only depend on the initial and final position, if a to V we can shifted the body A to B, then the work done of the body only depend on the position, initial position and final position, but how the body travel A to B it not depend. Okay, this is defined conservative force. That means the body will be travel A to B in different way. Okay, so the body not depend on the way how travel A to B. This is only depend on the initial and final position. This is depend conservative force. Okay, but in non-conservative force, when the body passes through some dissipate, the body will be dissipate some energy due to the some resistive force, or as like frictional force and any other type of force that against the body reduce the total mechanical energy of the body. This is known as non-conservative force. Okay. So okay, here we will be discuss the principle of the conservation of mechanical energy. So mechanical energy generally define the total kinetic energy and potential energy. If we body total energy is not dissipated in the form of friction, either dissipative force, then the total mechanical energy of the body must be conserved. Okay, the body mechanical energy of the body will be conserved if they are absent of frictional, either any dissipative force. Okay, so it will be discussed in very easily. That means total mechanical energy of the body, total mechanical energy equal to mg. We think the body lifted against the gravitation from each height one point to another point. Mg is equal to the potential energy and the kinetic energy with the body mass move with a velocity v square. Then this total energy will be conserved if absent of any dissipative force and frictional force. Okay, so this is the principle of the conservation law, and we will be stop here, and we will be for your in your syllabus work energy power we will be discuss up to this point, and next class we will be discuss next chapter. Okay.